Hey, so it's been a really long time since I've been involved uh, in making anything or documenting anything. This is the beginning of a commitment to change that. I think I got burnt out on trying to type stuff and make detailed articles only to have people come back and bitch about how they weren't detailed enough and um, etc. So I'm gonna try something different. I hear that's really good for Alzheimer's. Well, I should say prevention of Alzheimer's is to continually try to do something that you've never done before. So video production is not something that I've really put a lot of effort into. I've done some how-to videos, I've done some demonstration videos, but never putting my face in front of the camera. That I think I did it once, and it was really hard for me. Kind of like now. So that's where I'm at. Looking at what's going on online right now. I believe that if you know Mia Zlanovan, then you probably know that I have a website, and that website has been blank for a while now. I say blank, it hasn't really been updated for a while now. The last project that I really updated was March 18th. And this is really the sad nature of things is when I first started hacking, that was back in January 2013. It was this monster of a little robot. I still remember this electrical tape and putting this up on that under the lamp and taking a picture, thinking, man, I'm so proud of this. It looks like a creation out of the movie Tank Girl, which is awesome. I don't care who you are, whatever. It's a good movie. So yeah, that was the thing that really began it all. Wow, that's my kid. This was probably the closest I came to actually being in a video. Not gonna recap that. As you can see, my writing style here was very much still collegiate. I was used to APA. I think I even really automatically put a discussion section in to the document because everything I had written up to now that was documenting things included a discussion section, so obviously I was going to put it here. I miss this. I like the structure. So yeah, that was, I think, my first real project. The Hunter Thompson board, I think this is when I realized electronics would probably be an ongoing obsession with me, even though it's a hobby. I hate that word, but it's a hobby. It would be an obsession. I tried for probably 3 months to make this little bitty board right here, which is at Mega 250 or 2560 clone. But I tried for 2 months to make this at home using the lithographic method of PCB production, as you can see right there. That did not go well for me. It was a bit of madness. So many blanks, and what it really came down to is it just the sulfuric chloride that I was using. I don't think that my methods, well, the traces were so small. I think it had 8 mil traces on it, and the traces were so small that it was getting to the point where the sulfuric chloride would actually wash under the traces and dissolve them from the bottom up. So it wouldn't work. The other problem that I ran into is I was creating film transparencies at Kinko's and FedEx, I think. Yeah, FedEx. And both were crappy. They were really bad. The it got to a point where the copies were the scale was off, so there was no precision, or there was little precision to it. Not enough precision for what I needed. Anyways, so I've discovered Osh Park, and I realized the power of cooperative board fabrication, and that is that you can make that same board for $3.60 a piece. One. When you factored in the cost for ferric chloride, for the plastic exposure material, I forget what it's called right now, but anyways, development. The development chemicals and the time and effort, and then on top of it, I hadn't even gotten to the point where I was going to drill my vias, so it was not worth it. The one thing that I really took away from this project, though, was at the time I was I'm always going through head stuff, but this was a special time that I was going through a lot of crappy head stuff, and I was reading Hunter S. Thompson, which is never a great idea when you're going through heady stuff already. But Hunter S. Thompson, I had read a biography about him, and one of the things that he did was he was actually a veteran, and I can't remember what branch he was in, but after he got out of the forces, he went to work for a copy editor, is that right? But he would use his spare time, since he had a typewriter, he would use his spare time copying The Great Gatsby by hand. And he was quoted as just saying, "I wanted to feel for the music of such great words." Anyways, I generalized this idea to PCB production, and that's really what I think a lot of hackers like myself do nowadays. You know, we get on SparkFun.com, we get on Adafruit, and we look at these circuits that were made by brilliant engineers, and we pull them apart and we try to recreate them. And in the process of doing that, we are really learning by imitating their greatness. This is something I genuinely believe in. If we can just get a feel for what it's like to have achieved that level of greatness, that level of brilliance, I think then we're much more likely to come there ourselves. Just a note, the whole reason that I'm doing this video is just to get comfortable in front of the camera. Anxiety is a big issue with me. I have really bad general anxiety, and actually putting my face in front of where thousands of people, millions of people can make fun of it, that's I should be exploding right now. So, but I'm a believer that if you have anxiety, you just force yourself into the situations that cause the anxiety, and if you do that enough, you're either going to die or you're going to get over your anxiety. Your body's just going to respond by not producing the chemicals that are really corrosive as a result of the anxiety. So that's what I'm doing. So if you're bored, that's fine. Turn this off. This is for me. It's not for you. It's not for you. It's for me. But I'm going to continue to go through my projects because it's fun. It's like looking through a scrapbook, but not a scrapbook because I'm a man. Let's see. My Eagle PCB walkthrough. Oh, goodness. Yeah, I think I kept this one pretty simple. I don't think this is actually a PCB walkthrough. I think this was the process of taking a SparkFun design, ordering samples. So the design was for an EDXL 345 chip, but it was to take that design, have it ordered from Osh Park, order samples from, who makes that as a microchip? Analog Devices. What am I thinking? It's an Analog Device. Sheesh. Okay, so order the chip from Analog Devices as a sample. Yeah, Python. And then when you get it in, actually soldering it. Now, this is one thing that I think in my hacking journey, in my hacking journey, I did correct. And that was I skipped through whole components. This is a rant for another day, but to give you a preview, I think that the fear of through hole, excuse me, the through hole, the fear of SMD soldering really comes from never pushing yourself to experiencing it. Experience it. It's like the person that's 45 years old and never learned to ride a bike. They're going to have some trepidation about falling over, and rightfully so. They've never ridden a bike. It takes a lot of bumps and bruises to learn how to do it right. But once you've done it, it's strangely easy. I think that if you learn to ride a bike when you're 7 years or 8 years old and you're 45 years old now and you hadn't ridden a bike in between, you could probably still jump on it and within 10-15 minutes be right back to riding your bike like you were when you're 5. So, or 7 or 8. Not a math person. Hacker, not a math person. So I think that what people end up doing is they see SMD as this mountain to climb that they're just not ready for. They go to through-hole components, they get comfortable, and then they never move to SMD components. And that is just a shame. It's just a horrible, horrible crime. So, yeah. Oh, this is my favorite. It really, really is my favorite. For the other hackers here, you probably are in some sort of relationship, whether you're male, female, or somewhere in between. And I don't know how your significant other really takes your hacking, your making, whatever you want to call it. Mine has been pretty understanding because I've done things like this. I have stolen her clothes iron and used it for SMD soldering. In fact, as to this day, it's the only thing I really use. Well, that's not quite true. It's pretty much camera issues. Goodness. What's going on here, buddy? Hello, camera. What are you doing? Try that again. Sorry about that. Okay. To this day, that iron is what I use to do most of my SMD soldering. It's great. You just plug it in, you throw your PCB on there, and as long as you're only soldering one side, you know, you have applied your paste or your solder or whatever, good amount of flux, put your component on there, put it on the iron, plug it in, 2 minutes later, boom, your PCB is done. Your drugs are done. Your PCB is done. So we haven't had a clothes iron in a long time. Oh goodness, look, that's a 402 component. Yeah, so you may not be able to see that after all the video quality issues and stuff like that, but that little thing that I'm pointing at right there, that's a 402. If you have never soldered a 402 board, please do it before you die. It's just a lot of fun. It's like training fleas. It's like training a flea circus. It really is. You can't really see what you're doing. You think you're getting something done, but you never know until you plug it in and listen for the circus to just happen. So try it out. More soldering with a clothes iron. Oh look, the ADXL 345 worked. Yay. Witchery. So we got a thing for witches. We'll talk about that later. What else do we have in this old log? Oh, I remember that. The Mega Mini motor shield. the Mega Mini Motor Shield. So this was really my first personally designed PCB, and the idea was that this was supposed to have two SN754410, which are SN754410. All right, which are drop-in chips, H bridges for the L298D. But it was to plug in that Mega Mini and then ultimately go into my robot. Board worked. There were some issues. I had flipped around the LEDs that are supposed to light up whenever the H-bridge fires a particular direction. And there were a couple other, I think I had a routing error. I had routed to an incorrect pin. Ultimately, I never did anything with it, like so many of my projects. I was proud of it. Yeah. Why are those named the same thing? I think that's supposed to be my 80XL. So this is actually my Eagle walkthrough, which is crap, and I admitted to it. I was just really excited. It's like when you discover something that you feel nobody else has discovered, yet everybody else has discovered it. You want to tell everybody about it. I can think of a lot of good analogies, but nothing PG. So there you go. So you want to tell everybody about it. That's what I was doing. And then I think it was actually Birdman from LMR that piped in and said, hey, what about this video or this video or this video or this video? And I watched them and they were all better. So thanks, Birdman. Still doing. No, I love you, man. Platonically. This was, I think, my first real challenge at creating a board using very, very small components. So all I did was I grabbed the design files from SparkFun, shot them over to OceanPark, ordered some boards, purchased the components to populate it with from DigiKey, I think, and trying my hand at actually populating an Arduino Pro Mini with mixed results. This was my first real video setup. So this board was screwed into the ceiling right above my head, right there. If you look now, there's still a hole where I took it down. So the lab's been completely redesigned like 3 times. I think in my 3rd iteration right now. I'm just now getting the video equipment set back up. Like I said, I'm trying to make a commitment to do more videos. So I'm getting the video equipment set back up, but that board had come down and it actually held my first smartphone. So I think it was a iPhone 4. Was the first Apple product I ever owned, and I bought it because I had a new job, which is again another story for another time. But graduated 2007 from college, and if you know anything about that time, finding a job as a recent graduate, it just wasn't going to happen. So I was unemployed for a really long time. I ended up working at Starbucks for a little bit above minimum wage, and another job trying to support the family. So when I finally got a big boy job, I bought myself a smartphone as just kind of like a congratulations to myself. Back to the hacking. So this was my first video setup, and I was using it to actually video. I used it to actually video populating that Arduino Pro Mini. It was a great setup. That the iPhone had good video quality, but I think I needed to actually lower this a little bit so that I could get a better view of such small components. And there it is. So that right there is the, open it up into a new image. That helped. So that's the Arduino Pro Mini that I populated. I had purchased a AVR ISP MK2 that I still have sitting on my desk somewhere around here. Doesn't matter, you don't care. Not that this video is for you. Let's not forget that. This is for me, not for you. Anyways, so got it programmed, got it working, was very happy. Oh, yeah, I think he's still... It does not matter. ADHD, right? So it worked. That was the point. And it's around here somewhere. But I think I burned the voltage regulator out on it. So the guide, I cannot tell you how many times I come back to this picture right here, because I can never seem to, well, first off, I never put the ISP interface on any of my boards, and so it's never just a plug in go. I actually have to wire up each one in a breadboard, and I can never remember the wiring diagram for that stupid AVR ISP, so I just come back here and refer to it. Setting fuses, uploading the bootloader, boom. Arduino Pro Mini at home. I challenge you, yes you, to make an Arduino Pro Mini at home. That's meant to be motivational, not derogatory. Oh, here's one that I still love. So this was a sample that I ordered from, oh, I don't remember where the ADMZ 1250 is from, but basically the ADMZ 1250 is a galvanically isolated logic what would that be? Galvanically isolated logic shifter. Yeah, logic level converter. A galvanically isolated logic level converter. And I say galvanically isolated. I think originally when I referred to this, I actually called it opto-isolated, which is not correct. Opto-isolated is, I mean, it uses photodiodes and LEDs to actually opto-isolate the logic levels. This, however, uses if I remember right, it uses little bitty springs and magnets. Yeah, electric. Yeah, I won't get into it, but it's a really neat little chip. And it can handle, you know, serial I2C, and I think maybe SPI. So UART, I2C, and possibly SPI. I can't remember about the SPI, but it's a 2-channel. So it's really geared for UART or I2C. But there's showing how to communicate between 2 Arduinos. 80UM 1250 ARZ. Sorry, I haven't looked at these projects in, I don't know, 2013, Cali 6 years. Ooh, all right. Blueberry Pie. So this was my first real beefy walkthrough. And it is the process of taking or setting up a Raspberry Pi 1. Yeah, kids, back in the day when I built robots, all we had was the Raspberry Pi 1. So we had this, or this is the process of setting it up, remoting in, setting up a VNC, and then I think it had Python code to communicate, yeah, across I2C through the 80UM 1250 ARZ that we just looked at to an Arduino. And I still make the argument that that is a good setup. There's a lot of people that are like, why are you using an Arduino? I'm a hacker. AVR. Why are you using an AVR chip when you could probably do a lot of that directly from the Raspberry Pi? It's true. However, the AVR chip has ADCs already built in. It's 5-volt tolerant. It is, it allows buffering communication. That's, an oversimplified argument, but it really does. So it's a great lower brain. And I liken it, in a parallel to the human brain. You have the white matter at the front, that's, that's capable of contemplating the universe, but you also have the cerebellum at the lower brain stem. I guess that would be at the upper brain stem. But you have the cerebellum there that's responsible for muscle control, and it doesn't have to go all the way up to think about the moral ramifications of moving your finger when a snake's about to bite it. It just moves your finger, right? So I still think this is a good setup. I'll still make the argument that that's the way to go, is to couple, a microcontroller with some kind of larger processor. If you need a larger processor, for those of you who know me, my mentor, well, whether he wants to be or not, I call him my mentor, but William Cook, who goes by the handle of BDK6, and BDK6, he wrote a great article one time talking about how hackers like myself often are thinking that we need this huge processor with this enormous amount of speed, when we could accomplish the same thing with a much smaller processor if we just knew how to code, which we don't. I mean, I can admit, I don't know how to code. I don't know how to code well, that is. But that's why I do this. I mean, that's how I learn, is by actually putting my hands in it and trying something and breaking it and repairing it. Call us hackers, right? We hack into things. Anyways, so I remember where I was going with that. Oh, I think a lot of the times people use a large processor when they really don't need to. A simple microcontroller is often fine. I think BDK6's article is actually entitled, Arduino to the moon or something to that effect. But the gist of his article was the computer that got us to the moon the first time was, it was on par with a original Nintendo. It was on par with an Atmega chip. So to think that we need this 7.4 gigahertz processor to move a robot across the room is just ludicrous. It's absolutely ludicrous. All right, back to what we were doing, right? So anyways, this article walks people through setting that up and setting up the I2C communication protocol. I originally meant to chain together several Arduinos, AVR chips. Yeah, I meant to chain several AVR chips together on the same I2C bus. I don't think of the word. Same I2C bus, but it just never got to it. There's lots of other things we could have done, but as hackers, we have a tendency to really obsess about something, and then when we've accomplished one piece of it, move on to another project, right? If I'm wrong, who cares? It's my video. All right. I'm probably the only person that will ever watch this. And I'm not sure I'll watch the whole thing. Okay, so that was that. Oh, and then I did a true hack, and I hacked a USB port. What was I doing? Yeah, so I hacked a USB port to a battery, solar battery. What am I doing here? Oh, no, this was just adding a, that's what I was doing. So this was adding, I think, a boost converter to, to one of those USB battery packages so that I could run my Raspberry Pi off of it. Yeah, because I think the internal circuitry had a boost on it, but it wasn't producing enough power. There we go. It was fun. It exploded. I didn't do it right. Ah, OpenCV on a Raspberry Pi. So I mentioned earlier that, oh my god, that I put myself in front of a video one time, and that's what it was. This right here. Let's see if we can actually pull it up. How does video? Ah, screw you, Mario. Ready, 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 and there's the dweeb. Yeah. Oh my gosh, I've gained so much weight. Robots are not good for your health. I'm serious. Hacking is not good for your health. Like I think I'm going to become a biohacker, just to kind of restore myself. So personal goal right now is to get down to 195 before Rebecca graduates school in August, the first week of August. If I do that, she's going to buy me a MacBook Pro. Don't judge. I don't want a MacBook Pro. I don't need a MacBook Pro. I don't even necessarily like a MacBook Pro. But when you have a personal health goal like this, and you've also really worked your ass off to support a wife through graduate school, while taking care of, you know, the house and a job and everything else, and the kid. Don't forget the kid. Yeah, don't ever forget the kid. Don't leave him at school or anything. But anyways, it's good to actually do something to commemorate that. And if I can end it by getting back down to 195, then you know what, kick ass. All right, so I'm gonna buy the MacBook Pro, and you'll get over it. You will. Not that you're watching this anymore. You stopped it, you know, probably 55 seconds into the video. So here we are, 20 minutes, right? So anyways, I did look really worn out though. Okay, so that was yeah, that was a Raspberry Pi connected through that I2C galvanically isolated ADUM 1250 ARZ chip to, I think it was an Arduino Uno with 2 servos. And basically you move your face around and the servos will, excuse me, move your face around, OpenCV captures your face and then moves the servos accordingly. It was a fun project. Cheap USB camera. Much cheaper. Oh my goodness. Ooh. Old code. Notice the complete lack of comments. No comments. Old, like there's code in there that's just been commented out, but those are the only comments you get in there. Man, Mr. Cook would be shaking his head right now. Sorry, Mr. Cook. I'll do better. Maybe. Alright, so anyways, good project. The one thing that I remember about this project that I just want to take a second and talk about, and that was that LUTs. So Lumi. Yeah, Lumi was one of our LMR. I don't know if he was necessarily a robot elder, but he was definitely our wise, benevolent robot person, whatever you want to call that. And Lumi passed away. I guess it's coming up 2 years ago. Yeah, but Lumi was actually wanting to copy my code. Ubermentis, what is that? Wanting to copy my code, and that was a huge compliment. I'm not sure why. I had no comments in it. All right, BeagleBone Black. Oh my goodness, we're going to spend about 45 seconds here. Long story short, tried to jump on the BeagleBone Black bandwagon when it first came out, and it literally felt, I use this word correctly, it literally felt like I was beating my face into a brick wall. Oh my goodness, I'm not going to spend any more time on it. The one piece that I really enjoyed back before I got my LMR shut down, yeah, they kicked me off. We'll talk about that later too. Before they kicked me off LMR, BDK6 was making all these puns, and that's what you see here was our pun counter. How many puns could you make with BeagleBone Black? So it was dog puns is what we were doing. He ended up like 20. Destroying angstrom, not going to go into that. That was the Beaglebone black thing that is yeah, incomplete works. So goodness, I'm actually going to take a minute. I'm going to take a break before I go into this one. Hey, so got some more coffee. I'm going to try to finish this up before Silas wakes up. Yeah. Okay. Where are we? Incomplete works. So the incomplete works, that was me just getting frustrated as hell. So it was a collection of projects that I had started and I just did not have the skill level to complete. They included this pulse sensor. So originally there was some clever fellows who created this pulse sensor, which consists of a LED, a photoresistor, and a op amp, all in a very small SMD package. The problem was that, well, back up. It's the open hardware pulse sensor. The problem was though, at the time, the go-to hackers PCB tool was EagleCAD, and I couldn't find a good way to export Design Spark, which is what the pulse sensor was designed in. Couldn't find a good way to export those files and bring them over into EagleCAD. So I ended up looking at the schematic that the Open Hardware guys, or the Open Pulse Sensor guys made, restringing it together up in EagleCAD, and then once I had completed, shipped it off to OshPark. This is another plug that I'll make for SMD soldering real quick. Universe is trying to stop me. It won't happen. That's what I got the coffee for. So, SMD soldering. There's a reason that SMD components are so commonplace. In fact, I imagine in the future, other than major ICs and common resistors or common passives, it'll be very difficult to get your hands on through-hole components. In short, we're moving away from through-hole components towards SMD components because smaller is more efficient. It comes down, in the manufacturing world, the little I understand of it, it comes down to, the bottom line. And if you can make something in half the space, then you are potentially, theoretically, saving half the cost of goods. It's a way oversimplification, but that really is the gist of it. Now, if you take this logic and you apply it to the hacker world, specifically when it comes to, roll your own PCBs, SMD is the way to go. And the reason is you have places like OshPark that charge $5 per square inch. And you'll get 3 PCBs, but they're all the same design, and it's $5. So if you can, make that in half a square inch, then you're looking at $250. And so it really genuinely pays for the hacker to go with SMD components. And that's coming back to the pulse sensor. That's what I did here. Was I think this design, and OshPark charges for circle designs. So like this pulse sensor, they actually look at the square real estate. So even though this is a circle design, it's charged by the square inch. And so all that cutout area you're still charged for. But like I state here, the board was sent off to OshPark for $2. Super duper cheap. I mean, that's less than half a square inch. This is key, in my opinion, to rolling your own PCBs and really getting good at copying a design that you see someone else make and moving it over into your own design. you know, the concepts of object-oriented programming, for example, and that is you have this black box, and this black box has internal workings. It accepts certain inputs and it outputs certain outputs. And once you've established this black box and you have a consistent flow of inputs to a consistent output, then you can take that black box and you can apply it to any situation where you have those kinds of inputs and you need those kinds of outputs. So to move away from the abstract, what I'm trying to say is you can apply that same object-oriented mentality to circuit design. So I know that this is not that I know any electrical engineers. I can't say I've ever met an electrical engineer, but it just makes sense to me that you have these common circuits that are establishing or accomplishing a particular purpose. So you have a power supply unit, so a PSU. So you have a power supply circuit that is taking in a set, I say a set voltage, a variable voltage from 5 volts to 36 volts, and it's conditioning that voltage down to whatever input voltage the rest of the circuit needs. And so once you have built that circuit, you can then pull that circuit up and you can apply it into every other circuit you need a conditioned voltage where the input voltage is somewhere between 5 volts and 36 volts. So coming back to why I think SMD components and SMD design is really key to being a good hacker is you learn from experience. And if your experience costs you money, which it does, when you're literally paying for the square inch, you're paying for how much experience you get putting that circuit together. Yeah, so you get almost twice as much experience creating a circuit for a square inch board as you do half a square inch board. So you're literally paying for the experience. And where you make a mistake is if you do not condense your boards, then you're really you're losing out on the experiences. I think I'm stating this well. Come back. Let's say each component gives you 1 point of experience, right? And a square inch board is what we've got. Now, if we use through-hole components, we can get five components on that board. That's 5 points of experience, right? And it costs you $5. Remember, square inch? Okay, so now if we switch to SMD 805, so 0805 passives, we can put 20 components. 20 points of experience for $5. All right, not to even bring it to the fact that there's a possibility, and this is true, that SMD components, passives especially, cost a fraction of what through-hole components do. Okay, now bring that down to 402. Now we can fit 100 components on a square inch. These are made-up numbers, but that's not too far-fetched. You can fit 100 passives on a square inch. You now have 100 points of experience. Okay, so oversimplification, but I'm trying to drive the point home that if you can really reduce the size of your boards, not reduce the size, if you can condense your boards, then you are saving money that you can use to gain more experience elsewhere. Yeah. So coming back to it, I feel like one of the things I did right was start with SMD so that I'm comfortable with it, and then I moved. Well, I say moved. I hate through-hole components. You know, that thing that bugs me the most is that you have to sit there, plug the component through, and get the leads right and get them through the board, and make sure you don't stab your finger, and then if you do, get solder in it, and then lead gets in you and you die. Not quite that bad. But then you have to actually get the board held in a position where you can get to one side, but it stays put, and you have to hold the solder, and you have to hit it with the iron, and you have to make sure you have a big enough iron head that you actually heat up the solder, and then it sucks up into the via. It's just, I hate through-hole. Sorry, for you people that love it, I hate it. Coming back to the pulse sensor. All right, so You guys want to meet Ifrit? Ifrit, come here. Come here. So, I hate cats, but this is Ifrit. Ifrit loves me. I don't know if you guys can hear that, but he's purring. Now, don't forget, I hate cats. I really do. Don't tell him. I don't think he understands, but I hate cats. But have you guys ever tried to hate something that just loves you so much? And is this cute? Well, yeah. So this is my lab cat. Rebecca found him on the side of the road, and we nursed him back to health. When I got him, he had a real bad upper respiratory infection, and his eyes were matted shut. And it's like when I cleaned his eyes open, he just fell in love with me and has been in love with me ever since. So that's it for it. Okay, back to the pulse sensor. So the pulse sensor. I redesigned the circuit. No, that's not correct. I redesigned the PCB. So I copied the circuit, so the schematic. I copied the schematic into EagleCAD. And then I rerouted the PCB to try to make it as similar to the original design as possible. And I ended up with something about yay big using 402s. And I went through 4 iterations. In fact, this was one of, I think it was the first article I ever got posted on Hackaday, was I did the, I got the article that, Fellow of the Week, what they were calling it. Yeah, so Fellow of the Week article. Yeah, I'll take it. But I failed like 4 different times to get this pulse sensor to work correctly. It had to do with the op amp selection. So they have a SOT23 op amp here with 5 leads. So SOT23-5. And when you go to order it, you have to be super careful because they one of the types of the op amp, they switch the leads, and it's 1 letter different in one of the sub part numbers, and you just, yeah. So that was really the gist of it. I just kept getting the wrong op amp. The other problem is I can't really see it. Oh well. The photosensor is very, very small, and it has 5 leads on it, which is weird because it only uses 2 of the leads. I think that's right. 3 of the leads. Yeah, a voltage, a ground, and then an output. Anyways, what? Did you try to see I'm making a video here? Yeah. Okay. So the photoresistor was very hard to solder on there. And it was difficult because you put the photoresistor on one side using the close iron method, and then you have to flip it over and you have to hand solder all the 402s. Not too bad, except for there's a little diode on there that's kind of a bitch because it has no leads. It's like a leadless diode, and if you've ever tried to solder something with no leads, it's an experience. I mean, even like QFN chips have leads on them that you can hit from the side to actually heat up the actual pad so that it adheres, whereas this particular diode did not. To do over again, I would probably redesign, or I would switch out some of the components. But that's one of the reasons that I'm really going to start making some videos, is because I want to show people that you can take a circuit that someone has already established, so a schematic, an existing schematic. You can buy components that are comparable. You can re-roll them however you want, because that's the thing as a hacker that I want. I want to be able to put this schematic into this project. I will never be able to be an electrical engineer, a mathematician, a programmer, a software developer, an experimental psychologist, a data analyst, all these things that I want to be all at once. So I have to be able to be okay with taking someone else's good work, trusting it, re-rolling it into my own project, and running with it. And that's what I'm doing here. And irony. So Ifrit just attacked the computer mouse. Irony. That doesn't matter. It's poetic regardless. Okay, coming back to it. Rolling your own hardware. I think that's the way to go. Use established circuits as these black box objects, drop them into your project. As long as you're able to route a PCB and solder SMD components, you are good to go. Coming back to Incomplete Works. Okay, so that was the pulse sensor. It took me 4 tries. I finally got it working. Was ecstatic. So proud of that SOB. Then the HM10. So this is the board. This little module here is a Bluetooth Low Energy 4.0 module that's produced by, I can never say their name right, but Myanmar in Shenzhen, China. Sorry, Oddbot, if you're watching this. I know I really butchered that, but send me a pronunciation guide and I'll pronounce it correctly. It is a CC2540/41 chip, so that is a Texas Instrument x86 chip processor. And it is meant for controlling Bluetooth Low Energy, so it has all the Bluetooth Low Energy peripherals. The difference between the 4.0 and the 4.1 is that the 4.0, make sure I don't switch these, the 4.0 has USB peripheral, whereas the 4.1 has an I2C peripheral in place of the USB. So that's the change. I can't say their name, but the company that made this particular module programmed it with serial firmware, so it has a serial interface on it. They made it Bluetooth Low Energy compliant, although it took them a while to do that. Did not start out, even though it said Bluetooth Low Energy 4.0, it did not start out that way. Where was I? So yeah, they made this module, they FCC certified it, and I found it one day when I was looking for a Bluetooth module on Fastech, and I was completely ignorant. I've never even fired up a Bluetooth Low Energy module, but I was like, Bluetooth 2.0, that's so passe. I want 4.0 because that means it'll go faster and it'll be better. Yeah, I really did have that thought. So about these modules, thinking, well, I'll solder to the little edges there that are cut in half. Those are like, well, they're like vias cut in half. Those are called castellets. It allows the manufacturer, what am I trying to say? The person that is going to drop this module into a product, it allows them to easily solder it to their end unit. And the way these modules work, right now the FCC certifies a particular circuit like this. And they have this certification process called an intentional radiator, meaning that it's just casting radio waves out into the air. And to get something certified as an intentional radiator, I think it's $10,000 to $20,000 just to put it on the FCC's bench. So what companies will often do is they will look to a place like Huamao in China to actually create a module like this that's very small, program it, and then FCC certify it, where they can just drop it into their circuit, their end design. We were talking about black box circuits earlier. Okay, so drop it into their design, and they will bypass the intentional radiating certification. They still have to get a non-intentional radiator, I think is what it's called. Yeah, something like that. Certification, but that's like $1,000 as opposed to $20,000. So this works for everybody. There were some comments, some people I was talking to earlier that was talking about how the FCC is about to change this. From what I've read, that's not quite true. So this process will probably still hold true, although they have, FCC has recommended to router companies, not recommended, requiring router companies to prevent their hardware from being repurposed
and changing the radiating functions of the hardware from its original specs. However, they are putting the pressure on hardware companies to do this, not necessarily coming after end users. So there will be this series of chips, I'm guessing, that are older that don't have any way to necessarily lock them down, like this particular HM10. I can get in there and I can reprogram this. That's a whole nother conversation. Sorry, that hurts house. I can reprogram this using a CC debugger and the IRA, IAR compiler, Workbench compiler, which is like $100,000. So that's not going to happen. But I can use those tools to reprogram this pretty much however I want without getting it FCC certified. So I guess what I'm trying to say is that those laws don't really affect me as a hacker from what I've read. Not a lawyer. That little thing should go right here. Not a lawyer. Disclaimer, disclaimer, not a lawyer. Okay. Especially that kind of lawyer. All right. So that's the HM10. Now let's get to what I actually did with it. So the first thing I did was I looked through the data sheet and I tried to string together a PCB that would fit it. I sent off for it and it didn't work. Like it lit up like it was supposed to, but I could get no Bluetooth signal from, what was I trying to use? Oh, yeah. So we're cheap. We're pretty frugal people. Like my wife thinks that if I spend $5 that I've spent too much money. So she won an iPad mini for Christmas one year. And so we had an iPad mini. I told you I bought one Apple product. That was the iPhone. The iPad mini we won. I think every other Apple product we have, we've either won or it has been given to us. Yeah, so we'll talk about that later. So I was using the iPad mini, which was equipped with Bluetooth Low Energy. I couldn't find it. I couldn't, when you search for Bluetooth devices, I couldn't find this board. So I was like, what the hell is going on? Come to find out, if you put a copper plane under a radiating antenna, it actually kills the radiation from the antenna. And that's what I had done. I had put a copper pore underneath. I don't know if you can see it there, but there's a copper pore underneath the antenna plank on the HM10, which totally killed its signal. So again, this got featured on Hackaday's, Fail of the Week. But before I got it featured, I had already sent off the second iteration of the board with that in mind, because I could get the iPad mini so close to it, like I literally put it on top of the my HM10 breakout, and when I did that, I could pick it up. So it was like, okay, so something's killing the radiating signal. And then I did a little reading, and I'm like, oh, it's the ground plane underneath. Can't do that. So I had already ordered the Bob. I had already ordered the corrected PCB breakout, and I use a variant now of that. Actually, I need to revisit that. It's got issues, and it has for a while. Just sorry everybody that uses that. I mean, it's got like 30 stars on GitHub. I just haven't had time to go back and clean up the silk screen is mainly what needs to be done. Anyways, so Bluetooth Low Energy, scanned it, found it. So this is actually on the iPad mini? Yeah, I think. Picked it up, and we're in good shape. Couldn't get a dongle to interact with it, all sorts of other stuff. Got lots and lots of articles around this one little board. Had a lot of fun with Bluetooth Low Energy. The neatest thing about this project was I was a little podunk hacker in Texas. Sorry, I was born here. I'm not by choice. Anyways, I was a hacker in Texas, and one day after I finished this project and I posted it up as an Instructable, I got a weird email from a guy in China. He's like, "Hey, can I get you to, talk to me about, this project? I'm willing to pay you some money." What? I'm making minimum wage as a barista. Why the hell would you want to talk to me? So it was interesting. It helped me grow as a person because I realized that we as human beings, given our access to the internet, we can accomplish great things if we just set our mind to it and have a little bit of obsessiveness. And that we shouldn't let the hamperings of the world weigh us down to the point that we don't do great things. So, not that this was great, but it was great to me. Mind you, I have a mental illness. I was born in Texas. I was born in the middle of nowhere. Was raised in the middle of nowhere. I was homeschooled, graduated with a 5th grade education. Neither one of my parents had completed college education. My dad was a blue-collar mechanic all his life. So to come from that to get to the point to actually produce this thing that put me in contact with someone in China, I don't know. It was just, it made me realize that there's a world bigger than me. All right, enough fruitiness. Let's move on. This is a neat circuit. It's a circuit that I think every hacker needs to memorize. We deal with so many components that are 3.3 and then other components that are 5 volts. And this circuit right here really centers around the BS138 or comparable MOSFET. And what it does is it basically converts logic levels. So any signal that is sent to it, not any signal, up to a certain speed, any signal that's sent to it, it will convert it from a 3.3 to a 5, and vice versa. Of course, you can use the good old voltage divider to divide a high signal to a low signal, but that does not go both ways. So this circuit here on the left, 3.3 to 5 volt, is a bidirectional logic level converter, meaning that you can send 5 volts one way and it will translate it down to 3, and then the 3 will come, you can send the 3 in this way and it will translate it back up to 5. Boom, 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 boom. So it works for I2C as well as UART. It's a circuit we all need to know, and it's super duper cheap. However, to really do it right, you need to have access to the BS138, which is a SOT23 3-lead. It's a smaller component, not so small you can't deal with it, but it's small. So another plug for SMD. Oh my goodness, look at that LED. It was a huge LED. So one of the projects I had was trying to get lighting. I'm still working on it. As you can see above my head right now, there's this strand of lighting up there that I've put together. That's a project conversation for another time. So what are you doing? Yeah. But here I was trying to create lighting for my videos. The key to a good video, in my opinion, is lighting. So anyways, it just talks about how I was trying to create that LED, and then, the heat sink that I got to go with it, and the temperature, and all that. This is a project that never really went anywhere. I was trying to break out this this long distance, 1,000 meters radio. I never got past that point right there. And then my brain. Okay, so this is a SMD recreation of the Fuse Doctor, which is meant as a high voltage programmer for AVR chips. And anybody who's ever programmed an AVR, it has these things on it called lock bits. And if you put the lock bits in incorrectly, you basically brick the chip, unless you have a high voltage programmer, which this was meant to be. If you look at the routing on this, it is horrific. That's because I use the auto router. That's a conversation for another time, but never again. Learn to route. Learn to route, my son. Never really got anywhere with that one. found that it's just cheaper to buy another Omega. Sad but true. And don't screw up. It's cheaper to buy other Omegas and not screw up. There you go. Here's a drill press. I bought this from a rich guy in, I don't know, rich part of town. Sold it to me for 30 bucks. It looks exactly like Oddbots. I tried to point this out to him and he completely ignored me. So I'm doing it again now, Oddbot. My drill press looks exactly like yours. We're hand twins. Can you believe it? We're hand twins. Whatever. I get excited about these things. Moving on. I was trying to create a programmer for Omega chips so that I could just put them on this little board, you know, program them with the bootloader and then put them in my final destination. You know, it might actually have worked, but this is HDPE, which is cutting board, and I had printed out a TQFP 32 mask, and I was drilling holes in it with a drill press and then dropping pogo pins in there. The design theoretically would work. So this is, there's two pieces of HDPE right here, and the idea was I was then going to space these so that that HDPE would sit right there with just a little bit of the pogo pin exposed. But I just never finished it. I don't know what I was doing there. Thermostat. Oh, that's right. I was going to create Rebecca a thermostat. I'll do it someday. Probably about time. And then this last one was, oh, that's right. So I was trying to figure out a way to use DeskCC and GStreamer on Raspberry Pi. So GStreamer is this really interesting thing that basically sets up media pipelines through different modes of communication. That's about all I know about it, but it's open source, great stuff. Lots of people use it for other things. I was trying to set it up so that I could pipe OpenCV imagery to my desktop my desktop PC. The problem that I was having is that I was having to compile and recompile OpenCV in GStreamer, which would take forever on the Raspberry Pi. And I really wanted to harness into this new 6-core processor that I had bought and put in my machine that's right back here now called Echo. And I found that DeskCC will allow you to do, I don't remember the terminology for it. It's basically remote compiling. So I can compile a binary for the Raspberry Pi, but harness processors otherwhere on the network. I worked on that bee forever, and I was always running into issues. So, I don't know if I'll ever need to revisit it now that we have the Raspberry Pi 3 with its Raspberry Pi 3 quad-core. I don't know, whatever. Incomplete works. Look at that. We are almost nowhere near through. Everything else is much shorter. No, it's not. HM10. So here's the full post about that. You know, I liked some of these videos. These videos were pretty sharp. I liked the lighting on them. Here's that PCB. This one, the RX and the TX are flipped. I got a lot of nasty messages about that. Sorry. This is one. I'm just gonna want to talk from the heart here for a second. If you're gonna pull from one of my circuits, do not bitch about it. All right. I'm not a professional. I put my circuits up for you to look at and see if you want to recreate. But I'm not a professional. I put that disclaimer on pretty much everything I make. If you want to pull from it and you want to put it back together and do something else with it, that's fine. 2 things I ask of you. 1, don't bitch about it if it doesn't work. You should have made it work, right? Okay, that's what I do. 2, do not claim it as your own. Because honestly, a lot of that stuff is not mine. It's stuff that I pulled from someone else. Don't claim it as your own, buddy. Just don't do it. Don't do it. I had a guy that, we're going to get to a project here in a second, that basically ripped one of my designs and put it up as his own, and I was pissed. and I couldn't figure out why. I'm like, well, dude, you know, I've made this thing that's open source. It's open hardware. Why am I so upset about it? Um, I'm still not sure, but I do know that I'm much more careful about the projects that I borrow from and trying to make sure that the people that originally had the baby, the person that came up with the idea originally gets credit for it. Because thank you, buddy. Whoever you are, thank you. Thank you for sharing your ideas. So yeah, those are the two things. One, do not bitch. Do not bitch. Not a professional. Hacker, hacker, hacker. And two, make sure you give credits. All right. Coming back to the project. So HM10 showed you, how to put the board together. This was actually putting it into a robot, making things happen. And then there's all this discourse about what I wanted to do from there. And then I got really, really frustrated because the people that make the HM10, so the Wanamau, just take a second. I hope that doesn't sound racist. I'm not trying to be racist. I genuinely do not have the phonetic capability to pronounce the name of the company, but I know it's spelled like JNHAOMAO. So if somebody wants to send me the correct pronunciation, I'll do my best. All right. I'm not trying to be racist, though. Anyways, so I'm not going to harp anymore on this project. Let's get out of there. Dot Muncher. Oh, my goodness. I think this is the one that Max over at LMR got onto me because I originally entitled this project called Wobot, WOBOT. And apparently there was a real some bad blood with a guy that named his robot Wobot. I don't know. I had named it Wobot with a W because that's how my kid pronounced it. And that was the point of this particular project was I was getting... I'm trying to be a good dad. Didn't have a great one myself, but I want to make sure that I'm a good dad to my son. And I see that takes a certain level of involvement. And the problem with me, given my anxiety issues, is that everything causes me anxiety. So when my kid's running around, messing with my robot, I'm getting these anxiety spikes. So I was trying to think, okay, so how do I not have that emotional response? Because I want my kid to enjoy the projects that I have. And the only way that I can really do that is to, stop freaking out every time he picks them up, throws them across the room. And so it hit me that I needed to make a more robust robot. So that's this little guy here. I did things like make him out of HDPE, which is pretty tough. I wrapped things in tape and I bolted things down so that he could pick it up, he could throw it, and it wouldn't all fall apart. And I'd lose my $50, which for us back then was like all of the money that we would ever have. So, yeah. So I called him Dot Muncher because I would say like the biggest project that I've ever done, the one that I'm most proud of, was my Overlord project. And this was fairly simple in theory, and it's this idea that you use a static camera, so a fixed camera, kind of like this one right here, and OpenCV, so Open Computer Vision, to track a particular color. You connect this color with one of your robots, and then you send that information to the robot to create kind of a local positioning system. And this is something that is used, we see it all the time in quadcopters. So, you see that that neat TED Talk where the guy's throwing the quadcopter up in the air and, it flies around and, it's got the little balls on it so that it can identify where it is in space. That's basically what it's doing. It's using OpenCV to get a local position on it and then communicating it to the quadcopter. And I thought, well, why don't we have that for the hacker community? So that's what I was trying to accomplish here. And the most surprising thing is I pulled it off. I actually created a whole system that would allow this to take place. I've revised it a couple times, and the code is complete crap. I just hacked it together. But, you know what? It's there and it worked. It did what I was supposed to. A couple things that I would do different now, like I was using a magnemeter to actually get the directionality of the robot so that it could figure out not only where it was, but what direction it was heading. I think that what I would do now is much more in lines with what those fellows did with the new micro robot projects, putting on an LED on it or something to identify the front and the back of it, and then just using OpenCV to calculate where those are, to calculate a trajectory, so an angle, so that I know which way it's headed. Yeah, this was another tough time for me. So while this was going on, one of the reasons that I was putting this project together is I really wanted to have swarm robots, which I've not given up on yet. However, the whole purpose of having these swarm robots was I wanted to have a step up getting into an experimental psychology program. You know, I alluded to the fact that I have an anxiety disorder and that I've had problems with my education. But when I graduated with my bachelor's, which was a feat for me, I wanted to go directly into working on my master's. Well, the day I went to take the GRE, I had my first real panic attack, and I still remember that day. It was all the money I had in the world to pay for that test, all my money and my wife's money, really. But I found myself paralyzed in bed, and I couldn't move. So education is something it's emotionally charged for me. And you say, well, what does this have to do with this particular project? Well, I was trying to put the swarm robots together to give myself a step up into graduate school. And during this time, I was trying to find other ways into graduate school. Given that I had no money and I didn't have a great GPA, I still wanted to make sure that I got into graduate school. So I'm looking for back doors, because that's what I do. That's what hackers do. If something gets, slammed in our face, we're like, screw it, fine, we'll find another way to do this. We don't need your permission to be who we want to be. So that's what I started doing. And one of the things I did is I called up a local university and I said, hey, my wife and I are doing independent research. And we really wanted to, brush up on our researching skills. Is there any way that we can take a couple classes in graduate school, so an experimental psychology program, without actually being a graduate student? And they're like, oh, I don't know. Well, we're not sure about this. Why don't you reach out to the experimental psychology professor or the professor you want to talk to? So that's what I did. And I kind of schmoozed him. I was like, hey, buddy, this is Thomas, and this is what I want to do, and da-da-da-da-da, and just want to brush up on my skills and learn, what you have to offer before I actually get enough money to apply for graduate school. Well, he said yes, and a couple days later, I found myself in an experimental psychology class. I'm getting there. Stick with me just a minute more. I was in that class for about a month and felt really overwhelmed. I'll always feel like I'm inadequate just because of my upbringing, mentally inadequate. But one of the things that happened in this class was our professor disappeared after about a month. He disappeared. He was showing up every day. He was there at class time, Dr. Pablo Mora. But we showed up one day. He wasn't there. His graduate assistant, so we don't know where he is. We sat around for a while, then we left, came back, that was because it was a Monday, Wednesday, Friday class. So we came back Wednesday and still wasn't there. Nobody knew, but we got communication from, the faculty that, they couldn't find him either. Come to find out, Dr. Pablo Mora had driven north of Dallas, which was about 90 minutes away from UTA, which was the school, and hung himself from a tree. He killed himself. And it weirdly didn't affect me as much as I thought it would. So I've mentioned several times that I have a mental illness. For me, going to lock the door at night, when I lock the door, the person that is most likely to kill me, I am actually locking into my house. Right? Yeah. Suicide is this demon that will always be breathing right on my neck. And and I'm very open about it because that's how I protect myself from it. Um, so the fact that my professor killed himself, it didn't affect me the way I thought it was going to. At the time, I was working as a street outreach specialist, so I was dealing with people that were talking about killing themselves every day. I have engaged 41 people on the street that were that had been hospitalized for suicidality, and I was the one that made the call. So it's something that is always on my mind. Why would human beings kill themselves? And I think that at some point, bringing it back around. So, some point, I actually want to get a group of robots together and start programming suicidal algorithms into that group of robots. With an end to it if they actually do terminate themselves, which you can come to this article and you can read about my theory there. But if they end up terminating themselves, that it actually overcharges the battery or whatever and burns out the circuit. Sorry, long-winded explanation, but yeah. So Overlord, got a feature on Hackaday. Super duper proud of it. I don't know if I should be proud, but I am. One of the really fun moments was I actually put this up on Instructables, and it got ignored for forever. I mean, it got featured by Hackaday, which I appreciate. Thank you, Hackaday. Much love, guys. But for the most part, ignored by the hacker community. I don't think it ever really helped anyone. I mean, it was too specific. The code was bad. It was in Python. Just there was issues. However, there was one guy that left a comment in there that was kind of sassy. It made it sound like I didn't know what I was doing, but I didn't. That's why I was proud of it. I didn't know what I was doing, but yet I got it done. Well, I get weird about stuff like that. I'm like, why would you insult me? So I started doing my research on this guy, and come to find out, he's actually he was a fellow that was doing computer vision research for JPL, so Jet Propulsion Labs, so for NASA. So he was doing, he was doing computer vision research for NASA. So and this is a question that I pose people, when someone from NASA insults me, is that really an insult? Because to me, I take that as a heck of a compliment. My bachelor's is in business administration, not electrical engineering, not computer, not robotics, none of that. So I just thought it was funny. I'm like, dude, I mean, he was a brilliant guy. His article was absolutely amazing. But why would you take the time to insult me? That's a heck of a compliment. All right, bringing it back to it. So that's the Overlord project. And the reason that I call this guy Dot Muncher is because if you watch the Overlord video, I actually use my my kid's robot to be the robot that goes around and follows these dots and collects them. Jot. Ooh, Jot. That's this guy over here. So that's Dot Muncher, and this is Jot. Jot was a project, man. Here he is. So this was I was trying to design a PCB and a whole system, a whole robotic system that was less than $15 that I could use these swarm robots, and ran into some major issues. First off, I kept trying to do the shield design, so I was trying to create a let me back up and explain the design of the robot. So the robot is basically just HDPE that I was carving out because at the time I did not have a 3D printer. I was carving it out by hand, and then I had these two. Do I have a picture of it somewhere? Oh, look, there we go, schematic. I had these two continuous servo rotation motors. They were small servos, and they were continuous rotation because I actually pulled them apart and made them continuous rotation servos. This is I spent $15 on it, but if you count in all my time, this was a $1,000 robot. It was very, very time consuming. It was very time intensive to put together. The big failure on here was I was trying to use the shield design. So I had an Arduino Pro Mini, and then I had designed a servo board that was basically meant for 2 continuous servo rotation motors. And then it had a plug for an NRF. Crap, that's the most common radio module, but I've forgotten what NRF, the common radio. What is it called? Please hold. Didn't even list it in the bill of materials, but oh, there it is, the NRF 24L01. So how could I forget that? The problem with the design, like I said, was the shield that I was trying to put on there. So I had a shield on the Arduino Pro Mini, and then on the shield it was controlling the 2 servo motors and had the radio plugged in, and then I had built this in extension so that you could plug in another module, the HM580L, which is a Compass module. It's the module that's super cheap on eBay, and I kept burning components. I never really found out what I was doing wrong. I mean, my working theory was that there were cascading dropout motors. There were cascading voltage regulators on there, and I think that I was not producing enough current through the whole cascade. And it was, in the end, it was actually burning out the voltage regulators. Yeah. It was a fun project, though. So I think at some point I had given up after I burnt out enough modules. Yeah. I still have a whole drawer. HMC 5883L. That's the Compass module. I still have a whole drawer full of all the components that would go on this board. Probably never revisit it. Homemade pulse sensor. I don't know what that's put up here. That actually should have gone down. But yeah, there's that. Is that the op amp? I think that's the op amp. What the heck is that? I don't know. Anyways, so that's the pulse sensor. Attempt 3, which is the one I think actually worked. Friendly Overlord. So I revisited the Overlord project and I actually put it together as a Python module. That was, this right here is actually where I'm sitting right now. Again, Mr. Cook, sorry about the lack of comments in code. I will work on that. A Tiny Adventures. So, yeah, there's actually a video of soldering with the clothes iron. So I wanted to expand away from the Atmega 328 and start using other microcontrollers just because they were smaller and I could, going back to that whole less real estate, more experience, better at what you're doing. So here I was setting up the I2C communication between an A-Tiny and a Arduino. And I think the original intention was ProtoWorks, who is Stephen Wright. Hopefully I got your name right, Mr. Stephen, your last name that is. He had talked about a motor controller that was serial driven so that you could just send it serial commands and it would take care of all the cool stuff. So that's what that's what I wanted to work on. I was hoping to make it an I2C controller. There's actually an H bridge that's controlled through an I2C bus made by Texas Instruments, but it's like a $5 chip, and I think it only has 64 bits of resolution. This potentially using an ATtiny, it would have needed to be an ATtiny 84 to be a good one, and a a non-logic H-bridge. It probably would have been around the same cost, but much cooler. And yeah, you could have reprogrammed it. Oh, and it would have had a higher resolution. It would obviously it would have had 256 depths of resolution instead of 64. I did make this jig though, and this jig is actually one that I will need to remake, put a little more effort into it to make it smaller. But it's an SPI programming jig. It's my favorite. Like if I could have kept up with the footprint and remade it so it was a little bit smaller. And one of the things that I did not do on it was it really needs to be it needs to have reverse voltage protection on it, so that if you get it the orientation of it incorrect, that you don't actually fry whatever you're working with. Oh look, there's my OpenBench logic sniffer too. It's a story for another time. So anyways, yeah. Good projects. Let me take a.
All right, let's see if we can finish this up. Where were we? Let's see. All right, I was looking at the ATtiny 85 Adventures and the pogo pins. I think we talked about the jig. Coming back. Ah, okay. OLEDs. So, if you don't know what an OLED is, it's an organic light emitting diode, crystal diode. Really, it's a. I guess technically, OLED is organic light emitting diode. However, this is really an LC, organic LCD. I'm not doing a great job. So, it is a display made up of an array of OLEDs. So, an organic light emitting diode. And if you're not familiar with those, that's this little guy here. This little module is of $5. I think I got it from was that IT Studio? I'll have to look that up. But it's a great little display, and the neat thing about OLEDs, I can't remember the name of that. IT Studio. Where did I get those? Yeah, I'll go back to it and see if I can. I actually wrote it in an article. The great thing about these modules is that they are sharper, they have a greater refresh rate, and they have a wider viewing angle. So you can look at them from a less than a 45-degree angle and probably still get the idea of what the array is trying to display. So the image is trying to display. Let's see. IT'd. Why can't I remember the name of that? IT'd Studio. Anyways, this is just me interfacing that little display with, looks like there it's an Atmega. The one issue I really had with the modules that I got, they were not 3-volt compliant, 3-volt tolerant, so kind of difficult to interface with a 5-volt Arduino system. So ended up using the bidirectional circuit logic level converter that I showed you earlier, that has a BSS 138. I misspoke. That's a BSS 138. for bidirectional communication. All right, not much to say on that. 8 tiny bits. Oh, this is supposed to be my 8 tiny bitsy spider project. So this project was my attempt to combine a ATtiny85 with an HM10 module and create a very small Bluetooth low energy Arduino combo. And so the circuit would basically disconnect the battery from the load, and at the same time the 5 volts would run through a battery charger and charge the battery. So it's disconnected from the load, it's being charged, and all this happens while the 5 volts now also gets directed to the load and begins to power the load. So all this magic happens. It's load sharing, meaning that when it's unplugged, it's running off battery power, and it can go until the battery goes out. When you get it right in and you decide, oh, I want to add some charge to it, you plug the 5 volts in, and all of a sudden it's being charged while still running. So it never turns off. So just loved the circuit. I thought it was like really cool. Had some trouble getting it going, so this is my explanation of how the circuit works. It's a poor explanation, but yeah, Zach Kimball, definitely give that guy credit. I think that the whole thing worked pretty much like I wanted it to. The later addition was I put a coin battery on it so that it could be charged. So theoretically, this thing can be charged without ever shutting off. I did test that circuitry. Works great. Love it to death. Thanks, Zach Kimball. Later, I added when I built my 3D printer, I printed a little base for it to stick the motors in so that it bounced around. And then the last piece I added was I fell in love with the HM11 module, which is pretty much the HM10, but smaller. And so I don't know if I've got this article written up or not, but I've got this little board for the Scarab built. It's basically a logic level converter for the HM11. So later here in the video, I've got a little iPhone app that's basically controlling the robot through Bluetooth Low Energy. I love it. It was really neat. Couple issues. One, the motors were pulling way too many amps, and basically would pull so much amperage that there wouldn't be enough supply to the microcontroller, as you're seeing right here. Wouldn't be enough supply to the microcontroller, and it would basically lose connection. When I say microcontroller, I'm talking about the microcontroller on the HM11, so the CC2540. But it would lose connection to the iPhone and spin in circles. So, I mean, I could do the whole thing again and use much lower power motors. I found some, but I don't like vibration motors as a form of locomotion. They drive me nuts. They're horribly inefficient. I just don't think that for as much energy as you're putting them into the motors, you're not getting out the movement that it deserves. So, had it to do over again, I would definitely change the motors. And there's my 3D printer. Oh goodness, too many stories for this one. This was at another hard time in my life. Not going to get into, but yeah. So I built a 3D printer. Honestly, there was so much involved into it. I don't really want to recap it. I'm tired. I think the one thing I will say about the printer is that the reason that I went with a Cosel Mini Delta printer was Hoff 70, another fellow from LMR. He was our print expert, and he's the one that encouraged me. He's like, Thomas, Lodovan is what he called me. Lodovan, if you're going to build a 3D printer, then you need to go ahead and build a Delta. And
I would ask him why. I'm like, is it the print volume? Is it the, the quality of the print? Is it this? Is it that? Is it what, what? And he would kind of evade me, and he finally just told me, he's like, dude, it's because they're just so cool to watch. And that was his reasoning. And I have to agree, after I built the Costal Mini, which is sitting right over there, they are a lot of fun to watch. It's just a whole nother world. The sad part is that, not too long after I finished my printer, Hoff passed away, so he died. It was really sad. It really was. It was weird because we lost two very involved LMR members very quickly. I think they were a year apart. And it started, I don't know. It just, let's not talk about it. Yeah. Hoff, you are remembered though. Yeah, let's see, those are my files. So that's my 3D printer. Hoff told me, he's like, Thomas, don't skimp on the hot end. He's like, you can buy one of those hot ends from eBay, but you're going to kick yourself if you do. So it's the one bit of advice that I had to ignore, because although Hoff was a brilliant guy, I also had my wife on the other end saying, don't spend too much money. So I bought a eBay hot end, and for a year and a half I fought with that printer, never getting the quality print I wanted, and finally I broke down, and I ordered the E3D printer head hot end, E3D6 I think is what it is. Amazing. So I echo what Hoff says. If you're going to build a 3D printer, do not skimp on the hot end. Buy a good one. And Yamez, thank you so much. I wouldn't have been able to get that hot end onto my printer if Yamez, because I couldn't print a good enough quality print to print the adapter for the new hot end. Yeah, that's how much a hot end matters. So Yamez printed it for me and shipped it to me with a lot of other cool gadgets. Yamez, you're an amazing man. I really appreciate it. Moving on. The LPC 114. So I mentioned that I was trying to move away from I was going to say AVRs, but I mean Arduino. I was trying to move away from Arduino, and I wanted to access some of these neater chips, especially ARM chips. It's no. I mentioned earlier about we need to give credit where credit's due. The things that we've accomplished, whose shoulders we've stood upon. For me, that's been really one major person, and that's been Mr. Cook, William Cook, and he's just taught me so much. He's been very patient as I asked him some of the stupidest questions you could ever ask in the world of electronics. And so he started on this project where he was working with the LPC 114 as an ARM core processor with GCC toolchain, so it could be programmed using open source stuff. And the neat thing is it has a UART interface and comes in a DIP package, so you can actually breadboard it. So I bring all that up is that this is just an instructions on how to set up that tool chain in Windows for the LPC 114, and then how to run or how to upload, how to compile and upload a program that controls pulse width modulation. While I was doing this, I ran into an article. Why did I want bit banging? Oh, I remember why. So I was trying to write C code that can interface with the LPC 114, because I had this wild idea that I would write my own bootloader and that I would set it up with an HM10 and be able to that I would write my own bootloader, set it up with an HM10, and that I would be able to remotely put the LPC 114 into bootloader mode, send it because it has a serial bootloader on it, send it the serial information to put a new program on it, flip it again, pull it out of the programming mode, and actually run the program. Wild idea. And started this, let's see, when did this article start? May 2014. It is now it's June 2016. So 2 years. 2 years I worked on this program. Never got it done. I wrote it in C, so I was writing it from C as a CLI, so a command line interface tool, to program the LPC 114. I got it so close, and God bless Mr. Cook, man. Stupid questions that I would send him, because he wrote an uploader for it. I mean, he had his completed in, I don't know, a week. Wow. Probably a week of 20 minutes a day. But yeah, so I worked on it for 2 years. In all fairness, I really worked on it for a year and then gave up because I had other life hit me. 2014, about that time is when Rebecca started graduate school, and that's when I had to hang up my hacker shingle. So I took some time off, really. And I really didn't take time off from hacking so much as I took time off from documenting my hacks, which is not true hacking. It's not a hack until it's been documented. Until then, it's a silent whisper that no one's heard. Yeah, that's not good imagery, is it? Well, anyways, coming back to this. So I worked for 2 years on this program that would interface with LPC 114, and I wanted to write it in C because I wanted to learn C, just straight C, none of that C++ stuff for me. We'll get to some of the other articles about that bootloader here in a minute. Took a little time off, and I think I documented. Oh, why this article is kind of out of order. So I posted a article that Instructables on the HM10, and it drew a lot of interest from a lot of different people. Like I said, a fellow from China contacted me, one from Australia, and then one from the UK. Simon is his name. Simon is. I need to look him up. I should probably say hello to him. Simon is a fellow who was working on a kind of like a Kickstarter project for this thing called Carduino. So he was designing a robotics kit for kids, and he wanted to give it an app interface. And he contacted me about the HM10 because I was able to connect it to a iOS device. And he basically asked me, he's like, Thomas, what would it take for you to, write an app for this? I was like, I don't know. I mean, first off, never used a Mac in my life. Second off, I don't own a Mac. And third, I don't know how to program in this thing called, what are Macs programmed in again? So it's like, well, what if we give you money to buy a Mac? Okay. Now, mind you, how much did they give me? I think they gave me $300. So it wasn't like I was going out to buy a brand new Macintosh. No, I was buying a used one, bare bone kind of thing that I could write iOS apps on. So I think I ended up spending $600 on the Mac. So technically, I spent a little bit, and then I got $300 from another project that I'll talk about in a bit. But in my Mac, which is right over there, was paid for, no cost to me. But coming back to the project, so I had a pretty tight deadline. They were talking to all sorts of, or putting in RFPs, so requests for proposals for, grants and funds to finish the kits. They were meeting with venture capitalists and manufacturers, etc. So they had a pretty tight deadline. I think it was 2 months,
And I had to go from never having used a Mac to writing an iOS app in 2 months. Yeah, I don't think they were happy with the end result, but I got it. I did it. In the end, I wrote the app. It went, like, I got it published. We got it on the App Store. No, I didn't get it on the App Store. I finished the code. That's what I did. So I finished the code, and I was able to like interface with HM10, and that's what is seen here. So the app will actually move the robot around. Well, you saw that earlier. But I think by the time I finished it, they had already gotten a friend to write an app for them. So, sorry, Simon. I hope that I can return the favor someday. I'm better now, if that helps. I can write the thing in Swift. In fact, I've got a Bluetooth framework for you if you want it. I hope you're doing really well wherever you are, Mr. Simon. Hopefully you're in uni now. I think that's what you fellows call it. And you're, putting together other robotics kits. So that was my venture into iOS app writing. The Valdez Mutant. So I'm actually pretty proud of this little board. So this little board here it's pretty small. It has the HM11 on it, the one that I've talked about a little bit, which is HM10, just smaller. And basically they sacrifice I/O pins for a reduced size. At the center, there is a LPC114 and a QFN package. It has a logic level converter for the UART, so it uses the BSS138. RGB LED for indicating, UART communication, and then for Bluetooth low energy connection, there's a switch that switches the UART between the LPC114 and the HM11. The board actually turned out really well. I think I had to, I think I had one major error and I had to reorder the board after a correction, but I think on the second go it worked just as I wanted. It's kind of a butt to solder. Like I put these mounting holes on it because I wanted mounting holes on something. I was sick and tired of like having a finished product, like a finished board that I was really proud of, and I couldn't attach it to anything real well. So I put these mounting holes on there. So this is it. Like I originally set out to make it just as small as the Arduino Pro Mini, and in fact, I did pull that off, excluding the Bluetooth Low Energy. So there's another project that a guy did called the ARM Pro Mini, which is awesome. It's a really neat project that was completely unrelated, I think. Yeah, I think it was completely unrelated. But he did just that. He put together an LPC114 board that is the same size as the Arduino Pro Mini, and it's a lot sharper, has better buttons, and just cooler. Regardless, I'm still proud of this board. It's a butt to solder. This was my original take on how I wanted to operate, and in fact, this is how I currently have the Lumi uploader set up, which is my current project. So, but instead of an LPC114 on the other end, it's any of the 8Tiny or at Mega with the TSB, so the Tiny Safe bootloader on it. But the idea is pretty simple. The Bluetooth low energy modules that Humao makes allow you to set up this unit module B as a, what do they call it? Remote module, I think, remote mode, so that if this module sends it an AT command, it will intercept that AT command and do whatever the AT command says instead of sending that serial command onto the UART on the module.
meaning you can tell, using the USB device connected to the PC can tell module A to send the command to module B to flip a PIO, so an input. And that's what it does. So the module A sends a command to drive this PIO2 low, which actually, let's back up. That's how the Tiny Safe Boot works. Let's talk about how this one works, though, because I actually did get this to work. I just never finished the bootloader for it. So the way the LPC114 works is that it has two modes. It has a program run mode, and then it has a bootloader mode. And the bootloader mode is activated by holding the select line low while powering up the chip or resetting the chip. So what this setup does is the module A command, or the module A sends the command to module B to drive the 3-line low, hold it low, and then drive the second, or the PIO2 low and then high. And at this point, it is in the bootloader mode. It holds the 2-line high and the 3-line low. And the idea was, at this point, the bootloader that I was going to write and finish, right, is sending all the data to the bootloader to install the new program. And then at that point, the select line would be driven high. And then the reset line would be driven low, then high, essentially putting it back into the program mode, executing the new program, and off it goes. Man, I wish I could have finished this. At the time, like you said, I was trying to write it in C sharp. I was trying to write it in C, and I don't think I was very prepared. C is a tough language to write in. It's Mr. Cook says it all the time. C will let you do anything you want, even if it shoots yourself in the face. Which I think I did in a lot of my code. I had so many memory errors where your buffer, you run over your buffer. I was doing all sorts of crazy things. I've since learned how to program in C sharp. Not well, but I know how to program in C sharp, and that's what I've written my Lumi uploader in, is C sharp. So at some point, coincidentally, that's what Mr. Cook wrote his LPC114 uploader in, is C sharp. So more than likely, at some point, I will probably revisit this project, rewrite all my LPC114 uploader code in C sharp so that I can finish this project and check it off my list. All right, let's see if we can finish this up. Where were we? Let's see. All right, I was looking at the ATtiny 85 adventures and the pogo pins. I think we talked about the jig. Coming back. Ah, okay. OLEDs. So if you don't know what an OLED is, it's an organic light emitting diode. Crystal diode, really. It's a, I guess technically OLED is organic light emitting diode. However, this is really an LC, organic LCD. I'm not doing a great job. So it is a display made up of an array of OLEDs. So an organic light emitting diode. And if you're not familiar with those, that's this little guy here. This little module is of $5. I think I got it from was that IT Studio? I'll have to look that up. But it's a great little display, and the neat thing about
OLEDs. I can't remember the name of that. IT Studio. Where did I get those? Yeah, I'll go back to it and see if I can. I actually wrote it in an article. The great thing about these modules is that they are sharper, they have a greater refresh rate, and they have a wider viewing angle. So you can look at them from a less than a 45-degree angle and probably still get the idea of what the array is trying to display. So the image is trying to display. Let's see. IT'd. Why can't I remember the name of that? IT'd Studio. Anyways, this is just me interfacing that little display with, looks like there it's an Atmega. The one issue I really had with the modules that I got, they were not 3-volt compliant, 3-volt tolerant, so kind of difficult to interface with a 5-volt Arduino system. So ended up using the bidirectional circuit logic level converter that I showed you earlier that has a BSS138. I misspoke. That's a BSS138 for bidirectional communication. All right. Not much to say on that. 8 tiny bits. Oh, this is supposed to be my 8 tiny bitsy spider project. So this project was my attempt to combine a ATtiny85 with an HM10 module and create a very small Bluetooth low energy Arduino combo. And so it was my attempt to create this package, this combo. So you have the power of the Arduino hardware abstraction layer that you can interface with the ATtiny85, but you have the modern Bluetooth low energy going on here. And as you can see at the time, the approximate price point was $10.55, which was, I mean, it was fair for the little board. The board used 402 components. It had these little jumpers on it that allowed you to either to connect the UART with the HM10 module or to connect it to the ATtiny85 because you had to basically program the ATtiny85 with whatever Arduino sketch, and then no, I think I corrected that. I was going to say that you had to program it with the Arduino sketch using the ISP and then solder it so that it would interface with the Bluetooth low energy. But I think I actually had enough pins where I had software serial going on 2 pins. Does it say in here? Yes. Boom, boom, boom. Yeah, so it looks like there are 2 pins that I used for software serial. And then basically the rest of the pins were for the ISP. So that both could be connected to the ATtiny85 at the same time. It's actually really neat. I want to revisit this project because I've just finished the Lumi uploader. So that's one reason that I'm doing these videos, is I'm trying to kickstart. I like that word, but too many connotations now. I'm trying to have a kickoff of doing more tutorials with some of the homegrown projects that I've got going. And the biggest one that I've completed lately is that, I shouldn't say completed, it's still in progress, but it's the Lumi uploader. So this is my own UART uploader for the Tiny Safe Boot bootloader, and it allows you to either upload stuff to pretty much any ATtiny chip or Atmega chip using
UART. So it's based on the software serial. The Tiny Safe Boot Loader, neat stuff. If you get a chance, Google it, read all about it. It's pretty amazing. Well, kudos to the guy that wrote it, which I have not yet had any contact with. Neat fellow. It was written in assembly. I've looked through some of the source. It's pretty tight. Only real problem that I have with it is it doesn't really like baud rates over about 38.8. Has a tendency to be iffy because it uses software serial. Well, I assume because it uses software serial. So coming back to this project, so this ATtiny 85 and the Bluetooth Low Energy, I will probably revisit it now that I have finished my uploader that allows Bluetooth Low Energy to upload directly to the ATtiny 85. I know, pretty amazing. It made me really happy. People will ask me, you know, why would you do that? Why wouldn't you just get a Bluetooth Low Energy chip that you can, you know, interface with, kind of like the ESP8266. You know, why do we have this the ESP8266? They can do all the things that the Arduino can, and it's faster and it's cheaper. And my argument is it can't. You know, I would redirect you back to the argument that I made about the Raspberry Pi interfacing with the Arduino for robots. You know, there's some functionality that a 5-volt tolerant microcontroller brings to the table, other than just pure raw processing power. A lot of it can, you know, probably a lot of the same things using a second microcontroller can be accomplished using one microcontroller at a higher speed. But I think it takes a lot more effort and requires a little bit more sophistication when you're a hacker and you just want to plug stuff in and use an abstraction layer that's been created by someone else. Arduino's hard to beat. So anyways, coming back to this project, this is the project where I mentioned that I got really bitched out by a person because it's the way I had this wired up. As you can see, this little connection LED right there that lights up, actually blinks every 500 milliseconds, blinks on and off every 500 milliseconds. If the Bluetooth Low Energy is not connected, you can program the Bluetooth Low Energy module so that it will stay off completely if it's not connected and stay on solid if it is connected. So I thought, well, I'll use this and I will actually put a MOSFET on the as a drain on the ground of the ATtiny 85. So basically the ATtiny 85 wouldn't come on unless the Bluetooth Low Energy was connected. Okay, I mean, I thought it was a great idea. However, I think that what was happening was the pin, the pin for that connection LED can only source and sync up to 20 milliamps, and I don't think I had put a resistor in line, and so it was syncing over, or it was basically syncing too much, too many milliamps, and burnt it out. So this caused that LED to die, as well as the whole functionality of not being able to switch on and off based upon connection. Well, anyways, long story short, I got really bitched out by a guy, posted on Let's Make Robots, and you know, at first I took it to heart. It's like, oh man, I screwed this guy up, blah 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 blah. But I made it pretty clear in the article, like I reread my article, I made it pretty clear I did not know what I was doing, that this was all experimental and that copy at your own risk. So redirect you back to that earlier video where I stated, do not bitch if you're going to use my designs. If there's a problem, sorry, that's on you. You adopted the design. So I won't, and you're not paying for it. What? Yeah. All right, done. I'm done. Sorry. Another thing that I would probably do different is I would definitely include a decoupling capacitor, as you can see here. And I would switch from the HM10 HM10 to, and it wasn't out at the time, but there's an HM11, which is about, half, if not 1/3 the size of the HM10, which could possibly shrink this board even smaller, which would be pretty rocking. So, yeah. This is also the board that got copied. Let me come back to my face real quick here, and I'll see if I can find that Hackaday article. But there's a fellow on Hackaday, not a fellow on Hackaday, there was a I'm looking, but basically a fellow that copied my design and put it up on as his own. Yeah, here it is. So coming back, so he had this. Now, mind you, my article came out. Oh, when did I originally post this? Let's see what the date was. A Tiny Bitsy Spider. Where to go? A Tiny Bitsy Spider. January 4th, 2014. This article is February 9th, 2015. Right? So, guy basically just copied my design. Made a few changes, which is perfectly fine. I mean, that's what we do, right? We're hackers. We borrow people's designs, we move them to our own, we change them, and we go forward. You know, so we have this rolling. It's kind of like a collective mind. Each person takes someone else's design, reuses it, and hopefully makes one improvement, keeps it open source, so that you have this rolling design that continues to grow. This goes back to one of my favorite authors, H.P. Lovecraft. In his letters to other authors, he talked about the collective mythos that they were creating, and that the more that they wrote and borrowed from each other's ideas, that they were actually creating imagery that any writer could then pull from in the future. So I'm rabbit-trailing, sorry. There's reasons that I believe in this. You know, we borrow from each other's ideas, and then we build off of them, we improve them, and move forward. However, you need to be able to say, I heavily borrowed ideas from so-and-so. And you know, give credit where credit's due. And this fellow, I can't even remember his name. I don't even want to point out his name. Did not do that. He basically just threw this back together, called it his design, and went forward. Kind of pissed me off. I think I even made mention in here. Let's see. Oh yeah, there's his name. Error. And that was the other thing, is like he had asked me questions about, like he had been emailing me earlier about my design and asking me questions about it. So, I mean, he even helped the guy at one point. He also he copied one of my other designs, but he copied one of my mistakes. And so I don't think that he realized it was a mistake, ordered the board, because he put it up on Oshpark again as his, ordered the board, and I kind of felt bad. Of course, this was before he did this bit. Kind of felt bad, but you know what? Oh well. Yeah. So this fella right here, you know, he states, did you ever think you should have given proper credit to Ladavin, open source? Screw that, right? Sad, sad, sad. Reading about borrowing ideas from others, how I learned too. But I'm sure to give credit where credit is due. You, sir, can sod right off. Wow, internet is cruel. I was well into my project well before running across Ladavin's project. So if I look back at my emails, this guy, which we're just going to go with his name now, Micah Perlman. If I look back at my emails, I've got emails that demonstrate that he had been contacting me much before he released this. So, I mean, this is bullshit. It just straight up is. You know, and I do appreciate it. You know, Ladavin is super awesome, but I don't think I need to explicitly credit every website I had come across. And this is the part where I guess I'd like feedback from any community that wants to comment on. when do we look back and say, hey, I borrowed heavily from so and so's ideas? It was this amazing person that I stood on the shoulders of to accomplish this thing. I think it's important, but I do understand the point of if we were trying to do that, it's just monstrous. We could not go back and every little nuance that has changed in one of these rolling circuit designs for the open source community, give credit to everyone. So how do we do that? How do we balance it? And I ask for my own sake because I know how it feels to have a design copied and not referenced. I don't want to do that to anyone else. I don't ever want to take someone's idea, even implicitly. I don't want to take someone's idea, let it sink into my brain, and call it my own, unaware, and then turn around and state that it's mine and that I deserve any kudos for it. So yeah, I'd like to hear from everyone about that. So yeah, I think that's enough on that. Coming back to the project, that's not the purpose of this. Whatever, right? Close that crap out. Just booze and giggles. A tiny bitsy spider. I need to go back and correct this. Just so you know, this this website was put together very hastily. It wasn't put together very hastily. The articles were copied over to it very hastily when Robot Shop screwed LMR, and I got banned. Why did I get banned? Because I pulled my articles down, because I didn't want my intellectual property to be taken advantage of by someone who had no respect for it. Build a relationship, and that relationship will probably pay off. Don't build a relationship, and people will get away from you. It's, again, another rant for another time. But I just want to state that, you know, the reason that there's misspellings, etc., is, like I said, I was copying HTML, transferring it into... I was copying a Drupal article, transferring it into HTML, and then I had to convert it into this website set up in Jekyll, so it's a static delivered site. So I had to set it up in the Jekyll, and I just haven't had time to go back and correct things. Metallurgy. So I was trying to move away from Arduino. I felt like that's what real programmers, real embedded developers do. They don't use Arduino, right? So I started started by picking this random AVR chip called the ATtiny 1634. It's pretty neat. It's an ATtiny chip, so it doesn't have all the peripherals that an Atmega might. And it does have a couple neat features. It has 2 UARTs on it, 2 hardware UARTs. And it has the Q-Touch, which I never really got into, but it's basically capacitive sensing hardware. So it's a neat chip. It might be supported by the Arduino hardware abstraction layer by now, but at the time it was not. And so I just started digging in, and I wanted to learn you know, how things were done on, you know, just bare metal. Again, that's the reason it's called metallurgy. You know, I wanted to know, you know, a little bit above assembler, how I really interfaced with chips. And I learned a lot. Learned about bitwise operators. Before that, I didn't know anything about bitwise operators. Learned about registers and how microcontrollers hardware is changed by basically flipping switches and registers. And as you can see here, it's one of the smallest chips. One of the smallest chips. It's one of the smallest microcontrollers that I've ever soldered. So it's a QFN 20, I think. 510, yeah, 20. It's a pretty darn small chip, real small. Not a lot of room for making mistakes, but it's actually really easy. Don't let small scare you. It's an easy chip to solder. and it's cheap. I don't know if I mentioned that, but it's a cheap chip. It also, one of the neat things about it is it has a real not ultra, but it has a lower power mode that people, like, if you were ever going to make any kind of, I don't know, what would this be good for? Oh, let's say you were going to make an Arduino, not an Arduino, an AVR smartwatch. This would be a great little chip for that. All the programming set up. I discovered NewbieHack. Crud, I can't remember the guy's name. His articles are amazing. He does videos. I learned AVR programming largely from him, watching his videos. Highly recommend them. Went through bitwise operators, provided my own spin on an explanation, blah, 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 blah. I set up the ATtiny 1634 to interface with an H-bridge. That worked out great. Super proud of it. Yeah, you get it. There were several other articles in that series. I'm not going to go into them, but the AVR, so basically the same chip. I learned how to do pulse width modulation and then how to operate the UARTs, all using bare metal. Cobalt. This was a fun little project. I need to go back and give this guy credit. This is the image that I just stole off the internet. So Cobalt is it's building on that idea of having a really small robot controller. So the idea was, so this is a quarter. The idea was to have the ATtiny 85 set up with ultimately kind of like the ATtiny Bitsy Spider board. So it has this Bluetooth low energy module. It has ATtiny 85 as the controller. And then I discovered this, what is it, the DRV the DRV 8830 chip from SparkFun turned me onto it. But it's part of the DRV 8 series H bridges that TI makes, but this particular one has a I2C bus controller on it. So this is the chip that I mentioned that has the 64 bits of resolution, 64 bits forward, 64 bits backward. It's got a pretty neat little control protocol. So long story short, I wanted to set this up on the ATtiny. SparkFun had created a library for it to be used on the Atmega 328. So the real hard part of this particular project was I had to take what I had just learned about bitwise operators and low-level control, register control, and I had to write code that would do the same thing that the SparkFun library did on an ATtiny 85. I was wonderfully ill prepared. I was not ready for it. Spent way too much time on that project, but I did at one point. Where's my darn video? Yeah, here's a video. At one point, I actually had to Mario. At one point, I actually bought the OpenBench logic analyzer so that I could put it on this little Minimoto board. It wasn't the Minimoto. I built my own breakout because that's what you can do when you SMD solder. But I built a board and put a logic sniffer on it with the SparkFun library loaded up into the Atmega into an Atmega 328 and send it commands to analyze the I2C commands that the SparkFun library sent to it so that I could replicate it on the ATtiny 85. Again, that's what hackers do, right? It's not always about having the intelligence to get something done. It's about the perseverance and the creative thinking. My theory. You don't have to agree. So, fun little project. Ultimately, I found that the you know how familiar you are with the ATtiny85's peripherals, but it does not have a hardware I2C. It uses this thing called USI, Universal Serial Interface, I think is what it is. And so it's this really funky hardware that's supposed to be just that. It's supposed to be universal, that you can do all sorts of serial things with. Like I said a few minutes ago, I was wonderfully ill prepared. I was not ready to write, you know, low-level code to try to get universal hardware to act like, you know, ITC or I2C hardware. I wasn't ready for it. All that to say, I never finished it. I mean, I got the library working, but it was not reliable or robust. Yeah, great project though. It was a super small little robot controller. If I had finished it, it would have been pretty awesome. I think I'd do it different now though. I got some other ideas. Those chips, like I said, those little motor controllers are about $5 a piece, which isn't bad for an H-bridge, but they were a pain in the ass to solder, and just, yeah, $5, you make a mistake, you fry a chip. Yeah, no. I think now I would actually go with I think it's the DRV8837, which is it's the same series, but it's much cheaper. It's itty bitty. I'll have a picture of it here in a minute. QFN chip that has the same amperage and voltage, or similar amperage and voltage specs. And I would probably just use an ATtiny84 to control those. So I'd approach it much differently. Drop the I2C interface. Probably stick with just UART. All right, moving on. Where are we at? Advanced Dish HM10. So this article goes over Star Network. I was trying to create a Star Network for the HM10, and I don't know if I'm, to this day, I don't know if I'm using that term right, but the idea is that you have, let's say, three different HM10s, so 3 of these different Bluetooth modules, and they communicate kind of like a mesh network. They communicate with each other as well as a master. And I found that, unfortunately, the 4.0 protocol that's on these particular modules can only have one connection at a time. So I tried to create a workaround where the module would drop one connection and connect to the next module very quickly. But the quickest I could get that to go was, I think, 200 milliseconds, 300 milliseconds, because you basically have to disconnect, reset the module, then when it powers back up, you can disconnect, but the connected module is still trying to reconnect with the disconnected module. So you can't connect to this disconnected module until it times out. And so there was like a 2 or 3 second delay before it could connect. And I was trying to work around that. And so what I ended up doing was I would have one module send a command to the next module that it was about to disconnect, and it would send the command to a connected Arduino that would say, hey, I'm about to disconnect. The Arduino said, okay, well, I'll wait like 200 milliseconds. It would disconnect. The previous module would disconnect. This one would wait 200 milliseconds, and then the Arduino would turn it off and on again so that it would bypass the timeout feature. Horribly hackish workaround, but I got it down to 200 milliseconds. Regardless, still nowhere what I needed. I was looking at making it my primary controller for Swarm Robotics. So scratch that one. On this though, there is a new module that I ordered and I'm waiting for. So I think I mentioned earlier that the HM10 actually has a Texas Instrument x86 at the core. and it takes the IAR compiler to actually program it. That's where the toolchain is, and that's just horribly overpriced. A hacker just can't afford it. So you can't create custom firmware for it. And it would have been really neat, for instance, like the Star Network that I was trying to accomplish. The hardware is capable of it. It's the software that Hmao has written for it that is not. And so it'd been really neat to get your hands on the programming or the programming hardware and the compiler toolchain, compiler and toolchain, and program custom firmware on it where it would allow a Star Network. Because like I said, the hardware is capable, I think, up to 6 connections. And you can see this clearly because the Blue Giga, so the BLE 112 and BLE 113, which are, like I said, made by Blue Giga. These are Bluetooth low energy modules. The firmware that they put on those, well, back up. These are Bluetooth low energy modules that use the same core hardware. So it's using the CC25, 2540 and 41. However, the firmware on those is written so that it can have a Star Network. So bringing it back. So it would have been really neat to write custom firmware for these HM10 modules. In fact, it's been tried by a couple people. There's one fellow that actually got his hands on the IAR compiler and wrote, it's kind of like a bootloader. So it sits on an Atmega 328 that interfaces with the HM10 module, and you can send the binary to the HM10, the binary. I don't know if I know enough about this to explain it, but basically it's a workaround for the IAR toolchain. Pretty neat stuff. I'll have to look that up later. Okay, reason I mention all that is because I was looking on Fast Tech the other day, because I do that sometimes, and I ran into this little guy. So we have the HM16. And basically what this is, it's a drop-in replacement for the HM10. So it's a Bluetooth low energy module, but it's the 4.1. And here's the kicker. It's the 4.1, but at the core it has the Cypress. It has a Cypress, I think it's a ARM Cortex 0, I think. I'll have to look that up. Neat chip though. The reason that this is really neat is because the Cypress toolchain is not $10,000. You can buy what you need to program this little sucker with custom firmware for $50. Ha ha ha. So this is going to be one of my projects. I've got 2 on the way from China, on a slow ship from China. And that it's a 4.1 module, and if I remember right, one of the main differences between 4.0 and 4.1 is that they support mesh networks in 4.1. So there you go. Back to our projects. So that's the first one in this article, is that Star Network. Another one here, I was talking to Brassfly, who's that's his handle. He was an LMR resident. I think he's a refugee now, so he's on the Robot Rebels. Smart fellow, neat guy, really neat guy. He actually took up the SMD challenge, and he's now soldering SMD stuff. And he is actually an engineer, like an electrical engineer, I believe, something like that. But smart guy. He's the one that helped me work out this circuit, though. So I was having issues with getting the LEDs on the UART lines for my HM breakout board to light up correctly. So that's when I discovered, yes, I am that ignorant, but that's when I discovered that UART is actually active low. So to get an LED to work on it properly, to fire when there is activity, you basically have to sync it on the UART line. So for instance, if you want an LED to light up on the RX line, then you would need to provide the cathode with the 3.3 or preferably 5 volts. Have it go through the LED, run through a resistor, and then sync, so connect the ground or the anode to the RX line. And so what happens is whenever communication is going through, it's actually going low when there is communication. And when it goes low, then that current is able to flow through the LED, through the resistor, and into the same line and sync into the same spot as the current coming from the communication goes. You have to be real careful with this. The thing that Brassfly helped me work out here is that on the CC240 chips, that the UART lines, the lines that anyways that WOW uses for the UART, they can only source or sync up to 4 milliamps. And so he helped me work out the math on what resistors I needed to select, which I think is 470 for, I think it's 470 for red. I don't know, read the article. What was there for? And then the last one is just step-by-step instructions for, all right, mark the tab. Step-by-step instructions on how to upgrade the firmware on the HM10. So when the HM10 first came out, it was actually for the first, I don't know, I think it's like the first 20 versions of the firmware that they produced for it. It had no ability to be upgraded, meaning that you bought the module and whatever firmware it came with, that's what you were stuck with. I still have 3 modules sitting back here that have firmware that doesn't even, it's not even Bluetooth Low Energy compliant. Like, you plug them in and none of your, your iOS devices, your Android devices with Bluetooth Low Energy would be able to pick them up. So, however, I think it was version 18, maybe 18 or 20, somewhere in that area, that they enabled the HM10 to be upgraded, so the firmware could be updated. And it looks like 521. So this is just a walkthrough on how to do that update. I think they're up to 541 now or something like that. So they've probably had, I guess that's 41 different iterations of the firmware. I was very, very frustrated with those, whoever their technical writers are for their data sheets. I want to kick them in the ass. Very hard. Really hard. I've lost so much time on those data sheets. I don't know if it's one person doing all that, but it sure seems like it. It seems like it's one person writing the firmware, hand soldering each module, programming them, and then turning around and trying to write a data sheet. Because there were so many things that were omitted, and it wasn't just that they were writing a data sheet, they were also translating it. So there was lots of possibilities for mistakes, but they were bad. Some of the AT commands that you send it, like it was completely different than what was in the manual, and I had to guess. Like, I literally at one point I was guessing AT commands. True story, and I guessed some of them right. That's the crazy part. Yeah, so I was super excited when they made those modules upgradable. In fact, that's probably why I kept playing with them. If they hadn't, I would have quit. No joke. Moving on. Advanced. We talked about the metallurgy. Scarab. So I really like this little guy. The only problem is that, well, let's talk about him first. So at one point, I don't know, if you know the history of where I come from, and so I don't know if you know the history of where I come from or not, but I started on letsmakerobots.com. I'm not going to get into that today. That's a rant for another time. But I met a fellow there by the name of Yamez. His real name is James. I hope I didn't give anything there, James. But he is like the master of 2 things. Well, he's master of probably lots of things. But one of the neat things that he's master of is creating very small robots. Really small robots. So at one point he had created this itty bitty robot. Do I even have a picture of it on here? I don't think I have a picture of it, which is very sad. But but it was a very, very small robot that was driven by capacitor and vibration motors. And so he had a copper ring that connected to the capacitor that would allow it to charge. And at the heart of the whole thing, he had a PIC microcontroller. Really neat design, smaller than your thumbnail, awesome little things. So I wanted to design a PCB around it, which I did, and I sent him. I don't know if it ever worked or not. Yamez, I would like to know if it actually did work. But I didn't know how to program PICs. I mean, I knew how to program in BASIC, but I was not comfortable programming in a PIC. I knew more about the Arduino hardware, AVRs. Knew more about AVR hardware at this time and the Arduino hardware abstraction layer. So I thought, okay, I really like Yamez's designs here, but I want to be able to program them, you know, in the Arduino IDE. So that's when I created this design here. It's bigger. It's definitely bigger than his original design. And I never tested all the functionality on it. Just a lot, but not all of it. But it's an ATtiny84 at the heart. It had two infrared LEDs on the sides and sensors. It had two transistors to drive the vibration motors. And one of the neatest things that I put on here was a circuit that came from this fellow named Zach Kimball. Zach Kimball, you may have seen his work, but he did a he created a Atmega 328 watch. So it was like a smartwatch, real neat, had an organic LED display, just neat thing. But one of the neatest things he had on there, in my opinion, was this load sharing circuit. So he had a circuit that basically when you did not have it plugged into a 5-volt source, which was set up with a micro USB, I believe is what he had, then it would be drawing from battery power. And when you plugged it in to a 5-volt source, then there was this circuit that's designed to basically shut the to basically disconnect the battery from